So this week we'll be following up on our flies that we set up as a cross last week. We'll also be introducing the concept of complementation testing and setting up a complementation test that you can see how that works out. Okay, so as I mentioned, continuing the cross, setting up the complementation test. When you get to lab, you'll want to check your crosses that you set up last week. Remember where we left them off. So last week we set up a couple of parents. We had parents of one kind and parents of another kind. Those were true breeding males of one genotype, females of a different genotype. We had multiples of each, so up to 4 males, up to 4 females, and we were going to cross those. And if you remember the fruit fly life cycle, that should take about 2 weeks to go from those adults mating to the next round of adults. Now this week, you want to get in there and check. We're going to double check our parent phenotypes, so make sure that the males have the eye color you thought they should have, the females have the eye color that you thought they should have. A week on, you might have older flies, and you might discover that you had somebody misidentified last week. So if any of your males have the wrong eye color, females have the wrong eye color, that basically indicates that not every one of the crosses, male-female combinations, is going to turn out as you expected. And in a scientific lab, that would basically be something you scrap. Now in our lab, we don't have a chance to redo anything. So we have a certain number of weeks in the semester and we just keep going. So we're going to proceed with whatever you got, but if anything comes out unexpected, this is a good chance to make a note about that. So there's a chance when we get to next week and we see the offspring, your offspring also might be unexpected if your parents are unexpected this week. So you'll be able to kind of fill in the blanks and figure out what happened if things come out differently than you expected, and you have some observations that tell you that maybe things weren't going as you planned. Still a good way to learn about science, and if the offspring are not what you expected next week, we can recover from that by borrowing some flies from a neighbor whose cross worked a little bit better. So here we have just the steps for what you'll be doing in the lab this week. So checking out the adults after you anesthetize them. We're going to discard the adults because otherwise those adults would have a chance to mate with their offspring. So fruit fly parental generation, we want to isolate that from the F1 generation, and the easiest way to do that is to throw away, put them in the morgue, the parental flies, before we get any adult flies from the F1 generation. So we'll check the phenotypes and remove them. And we also want to check today and make sure that there are some larvae in the test tube, or the vial. There should be at this week some like white larvae squirming around in the food. They're like white larvae on top of white food. They're a little hard to see. You might see their black mouthpieces kind of moving around in there as they eat the food. If you don't see larvae this week, it may not be the end of the world. You may still get offspring next week. But also not having larvae this week could indicate that you might not have larvae next week. So like I said, we can't really undo or redo anything during this semester, but taking notes about what you get, whether the larvae were present and the phenotypes of the adults, all good information to have this week. All right, we also introduced last time, or during the course of lecture, we've been introducing the idea that not every gene is inherited in a Mendelian fashion. And one of the deviations from Mendelian is if we have something that is X-linked, so gene located on the X chromosome. And this week we'll be talking about the locations of genes. Your group might have learned about the locations of the genes that you're studying. And if any of the genes that you're studying is in fact located on the X chromosome, you might have to change your prediction. So last time we made predictions about the outcome of this cross, assuming, before we knew where these genes were located, we were assuming that they were autosomal, or genes not located on the X chromosome. So we're going to want to revise that prediction, maybe. So we're going to work out what might happen as far as your expectations, depending on whether you had a X-linked gene. So I'll start a new video here and we can go over the potential crosses there.